Good afternoon, my YouTube viewers. It is Crystal here. And what I wanted to talk about today was I wanted to do a code review on a binary classifier with a neural network made in numpy. And so basically we're going to go through that. We're going to go through the code for that. So I've created this program in Google Colab, which is a free online Jupyter notebook hosted by Google. And Google Colab is a great platform to make your Python products, with the exception of the fact that it does not have an adequate undo function. So you need to be careful not to accidentally delete or overwrite valuable code, because you may not get it back. And the only way that you would be able to get it back is to go through the save history, and you may be able to get it back that way. But the first thing we're going to do is we're going to, after we've created our Jupyter notebook, what we're going to do is we're going to import the libraries. So we're going to import numpy as np, and that's going to create your neural network. And then we're going to import sklearn, and that's going to import your breast cancer dataset, and import train test split, and import standardizer, standard scaler, because sklearn gives you your machine learning functionality, and it's a great library for machine learning. So after we have imported the two libraries that we need, we're going to load the breast cancer dataset, which is an sklearn's toy dataset. So data equals load breast cancer, x equals data.data, y equals data.target. So your x variable is your independent variables, independent features, and your y variable is your label or your target. So after we have defined our x and our y variables, then what we're going to do is we're going to use sklearn's standard scaler to scale the x variable, and you're going to use the mean and the standard deviation to do that. So scalar equals standard scalar, x equals scalar.fit transform x. So now your data is scaled. And it's based upon a standard deviation. That's how they scale it. So the next thing we're going to do is we're going to split the data into training and testing sets, and we're going to use sklearn's train test split function to do that. So x train x test, y train y test equals train test split x y, test size equals 0.2, random state equals 42. Now what we've done is we have prepared the data. We prepared the x and the y variables. You've got your train set and your test set. So now what we're going to do is we're going to set up the neural network. And the neural network is going to use the sigmoid function and the sigmoid derivative. So you can see the formulas for the sigmoid function here on the screen, and you can see the formula for the sigmoid derivative function as well. So what we'll do is we'll say